Another good example for polar coordinate and radars. In this one, we have this rocket which is going just in the vertical direction, and this radar is tracking this rocket. And at this moment which is given, which is shown here, R is given. R is 9 kilometer. R double dot is 21 meter per second square. Theta dot is given 0.02 radian per second. And we are supposed to find the magnitude of the velocity and acceleration of the rocket, knowing just R double dot, and theta dot. We don't know what is R dot, we don't know what is theta double dot. So how we can do that? Let's write down the equations first. Velocity in the radial direction is equal to R dot. Velocity in the theta direction is equal to R theta dot. Acceleration in the radial direction is R double dot minus R theta dot squared. Acceleration in the theta direction is R theta double dot plus 2R dot theta dot. So what I have here, I have R and theta dot. So I know what is V theta, but I don't know what is VR. And also I have R double dot and theta dot. So I know what is AR. I know V in the theta direction, acceleration in the R direction. But I don't know what is A theta because I don't know what is theta double dot. And I don't know VR because I don't know what is R dot. So what should we do? Let's start with drawing or showing ER and perpendicular to it, E theta. I know VR is gonna be in this direction, and V theta is gonna be in this direction. So I know what is V theta. If I know this, I know combination of these two is gonna be the velocity, the actual velocity, which is on that straight line, right? So if the velocity is this, then V times cosine of this angle is gonna be V theta. So if I know what is this angle, and which is given 60, this angle is equal to 60, and this angle is gonna be equal to theta as well. I know V theta and also I know theta, so I'm gonna be able to find V, right? So V times cosine of theta is equal to V theta, which is equal to R times theta dot, which I have it. And also I know what is theta. So from here, V, the actual velocity is gonna be simply R theta dot divided by cosine of theta, which is gonna be equal to, if you put the numbers, and also be careful about the units, velocity is gonna be 360 meter per second. You need to turn R, you need to write R in terms of meter. And same thing for acceleration. As I told you before, we know what is AR because I know R double dot and theta dot. And we can do the same thing actually for acceleration. Acceleration in the radial direction is gonna be something like this. And we are gonna have acceleration in the theta direction, but we know combination of them, summation of these two, must be in this direction because we know the actual direction of the acceleration and velocity just they are just in the vertical direction because the rocket is just moving on this line, right? So if I know what is AR, then we know AR is going to be the actual acceleration times cosine of this angle or sine of theta. So I know the actual acceleration times sine of theta is equal to AR, which is R double dot minus R theta dot squared. I know all of this and also I know theta. So the actual acceleration is going to be R double dot minus R theta dot squared divided by sine of theta, which is going to be 20.1 meter per second square. 20.1 meter per second square.